Alright, people, finally, the last video of this series where I wanted to do all the past papers of this topic, PNC, and we are at the final chapter of this video. Hope we get through it easily. Here we go. Question 7 from the 2024 Summer P51 variant. The eight digits 1, 2, 2, 3, 4, 4, 4, 5 are arranged in a line. That means all eight are being arranged. That means it's a factorial question. How many different arrangements are there of these eight digits? Got it? Eight digits, eight positions, eight factorial. Does anything repeat? Two twos repeat, so 2 factorial, and fours repeat three times. So 3 factorial as well in the denominator. That gives you, let's get you the answer. The answer is 3360 ways of arrangement. Easy question, free 1 mark secured. Here we go. Next part states find the number of different, keep in mind, different arrangements, not probable, right? Of the eight digits in which there is a 2 at the beginning, a 2 at the end, and the three fours are not all together. Okay, first let's look at the twos. A 2 has to be at the beginning, a 2 has to be at the end. So 1, 2 plays here, 1, 2 plays here. We're gonna fix these positions, right? Why? Because it sorry, it is a different arrangement question. So it doesn't matter that this 2 occupies that position as well, right? They're just at both positions and they're fixed. Because if they move, they will repeat. So we just fix it and denote their value as 1. Just to tell our minds that something has been put there. Now, 8 letters say, so 8 minus 2 is 6. So we have 6 positions remaining. 1, 2, 3, 4, 5, 6. Now, in these 6 positions, the second condition has to be met, which is the 3 fours are not all together. Whenever it says not all, what do? We first find out the total arrangement. So let's find out the total arrangements. What is moving? All these 6 letters in these positions will be moving, right? Those two twos are fixed at the beginning and at the end. Only this 6 will be moving. So 6 factorial divided by anything that repeats. What repeats? Three fours repeat three times, right? And no twos will be repeating because twos are not in this 6 factorial, right? And three fours are repeating. So that's the total arrangement. Now moving on to now to find a not all, to satisfy the not all condition, what do? Total arrangements minus the arrangements when they were all together. So all fours being together, what would that look like? Let's get the scenario. All fours being together. So one, two, three, that's three fours. Box that up. Boop, boop, put it up. There we go. And yep. So all subtract all the cases when the fours were all together, right? And this minus sign will, this subtraction will cause that not operator to come into existence. Mathematically speaking, we've talked about it generally so many times. Let's make it more mathy, right? Anyways, so inside the box we have nothing. It's just gonna be one, and outside the box we have one, two, three, four, four factorial. There we go. And that, my friends, is your answer. Right? So total arrangements minus the arrangements when they were together to satisfy the not all condition. 6 factorial divided by 3 factorial minus 4 factorial. In this 4 factorial, nothing repeats. That's why I'm not divided by anything, by the way. And our answer is 96 ways of different arrangements. There we go, easy question. Moving on to part 3. Alright, so 3 digits are selected at random from the 8 digits, blah blah blah. Part C, find the probability that 3 digits are all different. Okay. Very good question. See, now we already know it's a combination question selection because we are selecting 3 out of the 8. Now, it is a possible selection question. How did I know that? Because they've used the word probability. What is probability? Whenever probability and selection are used together, we know it's a possible selection question, right? So our numerator has to consist of possible selections. Is that clear? Now, see, I've always mentioned that whenever it is a possible selection question, it always box the objects that are repeating, or but not always, only those that have a condition on them. For example, here if it would have said that at most one two, at least one four has to be in among the three digits, then I would have boxed the twos and fours. And if it only said that the three digits it must contain at most 1 2, right? So I would only box the twos and not box the fours, right? And the fours will just be selected normally with the rest of the non-repeating digits, right? Now here the funny part is there is no condition on any letter. So what do we do in a condition like this? I've told you, and whenever it is a possible selection question, we only box the letters, digits, objects up which have a condition on them, right? Here there is no specific condition on any specific letter, so we will box everything that repeats up. That's it. So the twos are repeating twice, box that up. Anything else and a different object, four is repeating thrice, box that up differently, and a non-repeating box has 1, 3, and 5. So see, now we're going to select from these boxes. Now, how are we going to select is our question. Three digits are to be selected. So 1, 2, 3. We have 1, 3, 5, and they have to be all different, right? So we need to select in a certain way. We have to decide all the cases in a way which allows us to put them all to allow us to have all the three digits to be different, right? So it's going to be first. Let's just put the non-repeating box here, 1, 3, 5. That is going to be just one simple case. It's selection, right? So I'm not going to rearrange them. 1, 3, 5. That's one selection. So that's just one. 3C3 is one, right? Because out of this box, three and all three are being placed. So one. Moving on to more cases. Now all have to be different. Actually, let's do one thing. Let's make a table. 1, 3, 5. If I'm selecting from this box, if I'm selecting from the twos, and if I'm selecting from the four. Okay, let's make a box and then think about it. There we go. Table made. All three from these, none from these, one from each. That's also all different. Um, what if I went one here, zero here, two here, right? Two here, one, two, and no fours. That's three. That's three. That's three. That's three. Anything else? Whatever. One, one, one. No, that's done already. Okay, 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 okay. Yeah, but I think that's pretty much it. Now let's start the working. Let's move this one as well so it's more clear. Move it right over here. There we go. Now, as per the table, let's make the cases. So that's the first case. The second case is going to be three positions. We have 1, 2, 1, 4, and 1, 5. So 4, 2, and any one of these, right? So 1, 4 selected from the three I had, 3C1. 1, 2 selected out of the two I had, so 2C1. And any one from the non-repeating box, 3C1, right? Out of the three fours, one is selected. Out of the two twos, one is selected. And out of the non-repeating box, one is selected. Why do I do it like this? Because this is probability plus possible select, probability plus selections, right? I need to consider that that one four that is taking this position, that one four that is being selected, that could be any one of these, right? Any one of these. That selection gives you all possible selections. I hope that made sense. Because if this was different selections, I would have just fixed this one four. It doesn't matter which four, right? Because if it mattered which four, that would be a repetition, right? That's why I would fix it. But here it is probabilities. I need to give all the possible outcomes. I hope that made sense. So every four has to be treated as a different identity. That's why I'm doing it this way. Third case. Third case is okay. Okay. What is the third case? Third case states that I have 1, 4. So 1, 4, and any two from the non-repeating box. So out of the three fours I had, one is selected, and out of the non-repeating box, which had three digits, and two are being selected. 3C2. Final case. Okay, I think it's the same thing. Yep. No, actually. Out of the two twos, one is being selected. Anyone is being selected. Better terminology is anyone. So out of the non-repeating box, any two are being selected again. I hope that is clear. Let's get you the answer. That's one, by the way. So one, okay, 1 plus 3 into 2 into 3 plus 3 into 3C2 is 3 plus 2 into 3. That gives you 34. All of this will add up to 34 ways. Now this is just your numerator. Please don't make this mistake. This is just your numerator. The denominator will be all the possible outcomes, right? Normal probability is all the possible outcomes. That is 8 Out of the 8 letters, any 3 are being selected, and that gives you your probability. 34 divided by 8 C3 is 17 over 28. I hope that is clear to you people. 17 over 28 is our answer. Moving on to the second variant. Here we go. I'll read up them before as I get some water. Okay. It states different arrangements of 10 letters in this word. So 10 letters, 10 will be 10 letters, 10 will be moving around, 10 factorial. Divide by anything that repeats. R is repeating twice. E is repeating one, two, three, four. 4 times. Anything else? G, none. N, none. A, none. T, nope. So we're done. That's our answer. Let's get the answer. 10 factorial divided by 2 factorial into 2 factorial, man. 2 factorial. There we go. Into 4 factorial. And our answer is a very huge answer, 75,600 different ways. Easy question. Let's move to the next part. Part B. How many different arrangements are there? The 10 letters in the word regenerate in which the 4 E's are together and the 2 R's have exactly 3 letters in between them. Now I've mentioned in the techniques video um, that how a question like this is supposed to be dealt with. Let's do that. Let me show you the method. So firstly we have 10 positions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All E's have to be together. 4 E's I have, right? 4 E's. Please, what mistakes did we make? We forgot the repetitions. That's something to keep in mind. We counted wrong. That's something to keep in mind. That's what we're going to make sure we do not do here. So 4 E's, 1, 2, 3, 4. Anything we want together, we box it up, right? Here we go. Now, what is the condition on the R? Simultaneously. The method is simultaneously satisfy the other condition, which is 1 R here, 3 letters in between. So 1, 2, 3. The fourth letter will come about here. We box this up as well because this whole is a one entity that will always be moving around, right? It's always going to have something in between. Now, how do we deal with that? We made the scenario. The scenario is perfect. Now let's deal with inside the box. First, inside the box I have nothing. It's because 4 factorial divided by 4 factorial, as the e's are the same, so this box will just be 1. Inside this box, the two R's will not be exchanging positions. Why? Because it is different arrangements. Keep that in mind. If it was probability, I would have done 2 factorial, right? Because both R's have to take both positions. But here, these R's are fixed. So 2 more ones I will add just for concept sakes. Now, out of the remaining letters, R's and E's gone. R's and E's gone. I have one, two, three, four. 4 remaining letters. 3 will take these positions inside the box and they will occupy this position inside the box and move about their own position to give you a different arrangement each time, right? The R's cannot move, but these 3 letters that selected inside the box can move, right? Now outside the box, first thing we do is always deal with inside the box. Done. Now outside the boxes we have 1 whole condition, 2 whole condition, 3. All these 3 objects will be moving around, giving you another 3 factorial. And that, my friends, is your answer. Simple method. 4C3 into 3 factorial into 3 factorial. Wait, what? Oh, there you go. So the answer is 144 ways of different arrangements. I hope that's clear. It's a very specific method that we need to employ. Moving on to the final part. Okay. Find the probability that a randomly chosen arrangement of the 10 letters in the word regenerate is one in which the consonants and vowels alternate. So the conditions is that the consonants and vowels have to alternate. अच्छा आगे भी. So that no two consonants are next to each other and no two vowels are next to each other. ठीक है. Probability, the condition in the numerator is is that they alternate. And yeah, when they will be alternating, they no none of them are going to be next to each other. That makes sense. ठीक है. So let's make a case. First, let's put the consonants first, right? So consonants, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Now let's place the vowels. Actually, we could do the universal separation method. Here we go. So 1, 2, 3, 4, 5, 6. If I do that, 5 factorial for these, right? And out of the 6, any 5 positions will be filled. 65 into 5 factorial. And all of them can move around about the same thing, right? And by the way, you've noticed I'm not dividing the repetitions. Why? Because this is a probability plus factorial question. And whenever there's such thing happen, we do not remove the repetition. Got it? So, but see, there's a problem here. There is a problem here. Examiner is trying to play us. What will happen is, out of the 6 positions I've unlocked, 1, 2, 3, 4, 5, 6, any five will be occupied, right? That's how combination works. But if any five, if it happens the way it happens, which is any 5 positions, that could mean 1, 2, 3, 4, 5. That would put these two consonants together, right? So the universal separation method is a no-no because one vowel here, second, third, fourth, fifth. These two consonants will be put together. A case could be like this as well. Something like this could also happen. 1, 2, 3, 4, 5. And these two consonants will be together, which fails the condition that no two consonants are to be next to each other. So that's something we need to take care of. So let's do this again. Let us do this again. Okay, so now, okay, so there's going to be multiple cases now. Consonant first, vowel, consonant, vowel, consonant, vowel, consonant, vowel, 1, 2, 4, 5, vowel, 1, 2, 3, 4, 5. Okay, in this, if we do it this way, if it is done this way, then a condition is met that the consonants and vowels are arranged in such a way that they alternate and are never next. And a consonant is never next to another consonant, and a vowel is never next to another consonant. But there's a problem. Guess what? See, in the arrangements I'm gonna make here, the arrangements are always gonna have a consonant at the first position. Now there's no bounding in the question, right? That a consonant has to be first. No. They've said nothing like that. So I will have to consider that a vowel also belongs to the first position and the consonants alternate in the front, right? So let's do it. And by the way, I'm going to force you to think twice, right? So this is one way of thinking. Another way of thinking is I arrange the vowels 1, 2, 3, 4, 5, and and now I'm going to unlock my position in such a way that the consonants alternate and satisfy my condition that they never cause two vowels being together. How do I unlock those positions? By this way: 1, 2, 3, 4, 5. Everything in between. Instead of putting one here, I put one in the end only. Only the last place is unlocked. This is not unlocked, right? Yep. And see, I have conditioned that. Now see, something funny is happening here as well. Another thing is happening. This way, in all the cases, a vowel would have always been at the end, right? And that is not something we've been bounded for, right? So we need to consider that the consonant also takes this last position. Okay? So, we made 2 cases. One alternation we are managing, and alternation we've managed um, that none of them are together. None of the consonants or vowels are together. Now let's do it. So here we go. So 5 consonants moving about into blah blah blah, and 5 vowels moving about blah blah blah. Okay? And I'm not dividing the repetitions. Why? Because this is a probability plus factorial question. Moving on. Next part. 5 vowels moving about their own positions. 5 factorial. Not removing the repetitions. I have unlocked how many positions? 5. All 5 will be occupied by the 5 consonants and they will move about their own position. 5 factorial. Same thing, right? Yep. That's just about thinking how you want to think about it, right? It's the same thing. So 2 cases: consonant first, vowels alternating, and then we have vowel first, consonants alternating in the front. So this is my numerator. This is probability, by the way. Do not forget. Probability and factorial together tells us that the numerator is supposed to consider all the possible arrangements, not the different, all the possible arrangements. But now we come to the denominator as well. So the numerator consists of 5 factorial into 5 factorial. Same thing has happened twice, so I can just do it multiply by 2 divided by all possible arrangements, which is just gonna be 10 factorial. And the answer we're gonna get is, there we go. So the answer I'm getting is 1 over 126. There, 1 over 126. That, my friends, is how we're supposed to do it. So please make your thinking harder, make yourself think harder, make your brain go crazy. Sorry about that. Because I can teach you the techniques, but I cannot make you think, right? So some techniques, some ambiguities like this can be encountered by you. I hope you will be able to deal with them. Simply think about what you are being bounded for, the repetitions, probability, and no counting mistakes, please. No repetition mistakes, please. That's something we definitely take care of. Moving on to the final part of the summer variants. Oh, that my mistake, by the way. These are summer variants. I've written winter, my mistake, my bad. Summer variants, variant 3. Here we go. Alright, so different arrangements, 9 letters in the word record. There's easy scene 9 factorial. I mean, do I even have to read a question like this anymore? And what does this say? Anything that repeats, 3 hours repeating. There we go. Yep. And E is repeating twice. I mean, do I even have to explain this to you anymore? I mean, if you watch the previous videos, this is just makhan to you. Butter, smooth like butter, right? Okay. Anything else repeating? D's, E's, R's, S's. Nope, nope, very good. This is our answer. Actually, just find the answer yourself, people. I'm tired. I came from a long walk. Walking is good, by the way. You should run, you know. A teacher used to always say, my teacher, Sir Waqas Khan in Karachi, if you know him, he used to say that we should not always be study freaks, right? We should always go for runs because it is good for the mind. And I don't remember the guy who laid the foundation of computer systems in World War II. Alan Watts? No, no, no. Maybe I don't know. Okay, he cracked the German machine, something like that, which was a code way of communicating in World War II that we needed to crack. That the Central Powers or the US team had to um, crack. That was something like that. If I might have gotten my history wrong here, but that guy used to run every day, almost every day when he was practicing his stuff. So running is really helpful. Do that. Do that. Do that. I might be making an example that is not true, but do that. It's good for your brain. Trust me. How many different arrangements are there of the 9 letters in the word recorders in which there is an E at the beginning, an E at the end, and 3 R's are not altogether simple? यार वही twos and fours वाला सवाल है ये. Same thing we did in the first question, right about here. See, one at the end, one at the beginning, and the E's are not repeat, and the R's are not all together. So let's just finish up real quick. I'm not even gonna talk a lot. You just get it, right? Because it's the same thing. So 9 minus 2 is 7. 1, 2, 3, 4, 5, 6, and 7. There we go. E's are fixed. Why? Because it's a different arrangement question. How do we deal with the not all condition? We find the total arrangements. What is moving is the question. Don't go for 9 factorial because the E's are not moving, they are fixed. So 7 factorial, anything that repeats, R's will be repeating twice, if I'm not wrong. Yep. This is all total arrangements minus when they were together. Let's assume them being together. Anything we want together, put that in a box. Inside the box we have 1. Outside the box we have 1, 2, 3, 4, 5. 5 factorial. Nothing repeats in this case, and there you go. Answer. I mean, that's how fast you can get it if you just understand the techniques and how it's working. Easy question, man. Come on, do better, examiner. 2400 ways of arrangements. ठीक है. I hope I was clear there. I went too fast, but you just look at the previous questions, dude. I'm very tired right now. Final question, I hope. Yep. There we go. Uh-uh. There we go. 9 letters are divided at random. Two groups. Group of 5, group of 4. Find the probability that the 3 R's are in the same group. ठीक है. Easy question. Probability plus selection means possible selection. So any condition on the R's only, so box the R's. There we go. And no need to box the E's. See, they are repeating. The temptation is there to box them up, but this is a possible selection question. We only box at something that repeats, right? So in my non-repeating box, remove the R's. I have 3 R's, by the way. I had 3 R's. Wait a minute, people. I have 3 R's. So this is going to be divided by 3 factorial. See? Shit. Dude, keep this in mind. We always take care of the repetitions, right? And do the counting. Count right. Don't be me. Let's fix this. Alright, so now the answer is going to be 7 factorial divided by 3 factorial minus 5 factorial. 720 base. My bad, people, my bad. But see, this is a good learning way that आगे जब सवाल पढ़ रहे होंगे आप, तो you will somehow there was going to be a link of the previous part, or maybe just something may click that yeah, 3 hours are being used here, and I've just removed only two. I've only considered two in the above part, so it immediately clicked and I fixed it. Always reference questions, reference parts as well. That helps avoiding mistakes. Moving on to my non-repeating, I have ECO, DERDS, ECODES. Oh, I had two E's. That's why I was confused. I see. Yep. I got it now. Now, two groups are to be made. Group of four, 1, 2, 3, 4, and group of five, 1, 2, 3, 4, 5. All the R's in this group once and all R's in this group once. That's it. Two cases are to be made. Let's make them. So, first case has all the R's in group one. So, out of the three, all three are in that group, right? And that would mean 1, 2, 3, one position left. So that's going to be filled by the remaining box, which is 1, 2, 3, 4, 5, 6. Out of the 6, 9 minus 3 is 6, good enough. 6 out of the 6, 1 takes that position, anyone. Moving on to the remaining 5, they will just occupy the next box, 5C5. Simple question. Moving on to the second case, let me just remove that. Let's try again. For the second case, all are in this group. So, starting off with the same routine, all with this, starting from group 4, right? Because I filled group 4 first in the first case, I will also fill group 4 first in my second case. But the R's are to be selected in group 5, right? So, I'm going to fill that group of 4 with the second group, which is out of the 6. So, 6C4. This group is filled. Now, moving on to 3C3 because all the R's are used. And lastly, that's 1, 2, 3, 4, 5. Two positions left, and in this box I had two remaining because 6 out of the 6 4 were placed. Two remain. Out of those two, all these two positions will be taken by them. And that, my friends, is all possible selections. So 6 into that's going to be 6. 3C3 into 5C5 plus 6C4 4 into nothing. There we go. 21 ways. There we go. 21 ways are favorable condition divided by all possible outcomes, which is just going to be 9C. Okay. 9C4 into 9C5. Oh, okay. 9C4. 4 have been selected. Remaining are 5. 5C5. There we go. We filled the four group of 4 first. Then we filled the group of 5. This is our favorable condition divided by all possible outcomes. 21 feels weird to me. I don't know why. But I don't think we made a mistake. What was the condition? Ours are in the same group, right? So 3C3, 6C1 into 5C5. Yeah, that makes sense. That makes sense. Group of 4, group of 5. That should not be a problem. And in the second one, I filled the group of 5 with the R's. So 6C4, 2 left. R's place 3C3, 2C2. No, yeah, that's correct. Good enough. 21 divided by 21 divided. Okay. 21 divided by 9C4 into 1/5. And the answer is 1/6. Ladies and gentlemen, that is all the summer variants. Let's move on to the winter variants real quick. Okay, so we move on to the winter variants. Here is your reference. Moving to the question. How many different arrangements are there of the 9 letters in the word intellect in which the two T's are together? ठीक है. So whenever you need something together, you simply box it up. So the two T's. Actually, let's make the 9 letters first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Anything we need together, we box it up. Please do your work neatly, it's important. The two T's are gone, so that leaves us with 9 minus 2 is 7. 7 letters remain outside. Now, so how do we do it? Well, after boxing it up inside the box, we have 1. Why? Because they repeat, so that's just going to cancel out. Then 1, 2, 3, 4, 5, 6, 7, 8. That's gonna be 8 factorial for outside the box. Does anything repeat outside the box? The two L's and the two E's. Anything else? Nothing. So 2 factorial, 2 factorial. That should be good enough. Yep, that's your answer. Just be careful you're counting it right and you are taking care of the repetitions. That is the most common error I've seen in my own papers and in the practice we've done together as well. That, my friends, is your answer. Moving on. Part 2. How many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end? Okay. So different arrangements, so let's just fix one T at this end, one T at this end. We are all out of T's, cancel them out from there. Remaining 7 positions, 1, 2, 3, 4, 5, 6, and 7. This is we're gonna play our game. We denote the fixed positions as 1, right? Done. So this part done. Now the two E's are not next to each other. Difference. Identify the keyword. If it said not all, we would have done the other method. But here it says the two E's that we have are not next to each other. That means that we need to employ the universal separation technique. How do we do that? What do we need to separate? The E's. So let's just forget about the E's. So how do we forget about the E's? Oh, where's my cursor? There we go. We forget that they will even occupy a space, right? We forget about them completely. So for now, I'm going to cancel them out. The remaining are 1, 2, 3, 4, 5. So the remaining 5 objects are going to move about their own positions to give you a different arrangement each time. And now we will unlock positions. The first one, everything in between, and the last one. Not before there and there. Why? Because the T's have to be each end. We are playing between the ends, right? So that's why I'm unlocking these positions only. Now, how many positions did I unlock? 1, 2, 3, 4, 5, 6. 6. Out of the 6, how many will be filled by the E's? 2. Any 2 will be filled by the E's. And they can move about their own position, but since the two E's are the same, they're going to repeat twice, 2 factorial cancels out. Right, and I'm sure that's it. That is it. So, your answer is simply going to be 5 factorial into 6c2. That gives you 1800 ways. Actually, wait. L's. What about the L's? The L's are repeating here right now. Yeah, Shukar. Ah, see. Please think about the repetitions. I immediately, reminded myself that I have not thought about the L's, something that repeats. So there is going to be a 2 factorial division here as well. So 1800 was the initial answer divided by 2 factorial. 2 factorial, we will have 900 ways. Okay, so please keep reminding yourself. Are you forgetting anything that repeats, or are we counting correctly? Right. So 5 left. L's were repeating. That's why there's a 2 factorial division here. Then 6 positions unlocked. 2 will be filled by the E's. The E's are not going to permute. Why? Because they will repeat. That's why there's another division here, and that cancels out. Remaining answer is 900 ways. Moving on. Part 3. 4 out of the 9 are selected in the word intellect. Find the percentage. Okay. Of the possible selections, ठीक है, which contain at least one E and exactly one T. Okay, wait. No condition on the else. Easy. Chal. Huh. Multiple ways to think about it. Firstly, let's about this percentage thing. This is just like probability. First, find the favorable conditions through your possible selection way, right? And then you will divide by all possible outcomes. So how do we do this? 4 out of the 9, right? So let's make some cases. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then we have 1, 2, 3, 4. Let's just start off with 4. Okay. So at least one E has to be our part of our group are 4 letters and exactly one T. No. Before we begin making our cases, what do we need to do? Anything that has a condition on them, we box that up. So the T's, I have 2 T's. Box that up. I have 2 E's. Box those up. Now, I have the remaining are just going to go in a separate box. So the T's and E's, forget about them. Remaining we have INLLC. INLLC. Yep. That is our non-repeating box, but since the L's have no condition on them, This is just going to be a box which contains all the remaining letters that have no condition on them. So let's start with the case. At least one E. So let's start off with one T and one E. Because one T has to be in our case and one more than equal to one E has to be in our case. So one T, two E's is one more case. And I think that's about it. Right? Such a basic question, bro. Remove that. There we go. Yeah, I mean, I don't think I can do anything else. At least one E, exactly one T. Yeah, yeah, yeah. And I do not need to worry about the L's. Why? Because this is a possible selection case. So nothing to do manually. If this was a different selection case, I would have, even though there is no condition on the L's, I would have done this myself. Manually, I would have thought about zero L's, one L, two L's, all cases, including that, right? But here, since there is no condition on them and the cases of possible selections, we can just forget about it. Now, let's do the calculation. So, where is this T coming from? Any one of the two I had. Where is this E coming from? Any one of the two I had. And how will these two positions be filled? Out of this box. 1, 2, 3, 4, 5. So 5C1, 5C2 for that. Plus our second case, 2C1 into 2C2. And lastly, from the 5, I have one position being filled. And that, my friends, will be your favorable outcomes. Divide by all possible, which is just going to be 9C4, and that will not give you your percentage. Percentage would mean multiplying by, finding out this fraction and then multiplying by 100, right? And no need for this as well. There we go. Do that. Yeah, let's find the answer. 2 into 2 into 5C2, that's 40, plus 2C1 into 2C2 into 5. Okay, so we get 50. 50 ways are favorable in our favor. Divided by 9C4 into 100 into 100. So the answer I'm getting is 39.68%. It can be rounded off to, you can give your final answer in 3SF, right? That's the direction given to us at the start of your paper. You can read it in uh, the first page. Basically has a bunch of instructions. If it is, sorry about that, I switched to a different window randomly. Anyways, where was I? Right. So it's mentioned on your front page of your paper sheet. It just says that whenever it is not specified how many SF or decimal places you have to give in your question, you can leave it in 3SF. I hope that made sense. And this is your part. Variant 1. Acha ji, paper 5-2. Here we go. Find the number of different arrangements of the 9 letters in the word algebraic. ठीक है. Algebraic, I don't know how you say it, but this is the word. Anyways, 9 letters का arrangement है, 9 letters moving about, 9 factorial. Anything repeats. A's repeat twice, divided by 2 factorial, and L no, G no, E's no, B's are no, nothing else repeats. That's it. Get your answer from your calculator, please. Moving on. Find the number of different arrangements of the 9 letters in the word algebraic in which there are no more than 2 letters between the two A's. ठीक है. अच्छा, wait, let me read this more carefully. In which blah blah blah, in which there are no more than 2 letters between the two. अच्छा देखा. See, the keyword here is no more than 2. Mostly they would say exactly 2 letters between the two A's, right? That would be your, instead of no more, they would say exactly. That would be your normal keyword. But here they've mentioned no more, right? Now what does no more than 2 means? No more than 2 means greater than equal to 2, right? So greater than equal to 2, yeah, that would mean no more than 2, because we can have one letter between the two A's, we can have zero letters between the two A's, we can have 2 letters between the two A's, but not more than 2, right? That's satisfied. So no more will resonate to greater than equal to. So what this question essentially means, if it does not use the word exactly, it means that I'm supposed to make 3 cases. One where there is no letters between the two A's, another with one letter between the two A's, and another with 2 letters between the two A's, but no more than that, right? So please don't let the examiner fool you here. Let's make the cases now. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so first we're going for a zero A's, zero letters between the two A's part. That would simply be putting them together, box them up, and inside the box is going to be 1, outside the box is going to be 1, 2, 3, 4, 5, 6, 7, 8, and that is going to be 8 factorial. That's your first case. The other case is having one letter between the two A's. How do we do that? Let's figure it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. By the way, in this 8 factorial, does anything repeat? Anything moving around that repeats? Nothing, only the A's were repeating. Okay. Always question that, please, and make sure you count it right. Those are two things you always question. Okay. So the other cases having one letter between the two A. So that is one letter. Now what do? We simply assume this as one case and think about the arrangement. How do we do that? We say these two A's are fixed in their positions, right? For this specific arrangement. And the rest of the 9 minus 2 is 7. The rest of the 1, 2, 3, 4, 5, 6, 7 positions, anything that occupies it are moving around to give you 7 factorial. Does anything repeat? Nothing repeats in the 7 factorial, right? That is for this specific case. But what if we have to think, what if this A moves here and this A moves here? This spot will still separate the two A's, right? An A here and A here. So this will happen again. This same arrangement will happen again when this A moves here, this A moves here. So just a shortcut is to get to know all the cases this condition of having one letter between the two A's to be satisfied. What did I teach you? One position this, second, third, fourth, fifth, sixth, seventh. That was 7 times, so just multiplied by 7. That's it. That's your second case. The third case is going to be having two letters between your A's. So 1, 2, 3, 4, 5, 6, 7, 8. There we go. One A here, two का gap, दूसरा A यहाँ आ गया. Now think about this specific arrangement. 1 into 1 for the A's, and then you have the rest of the 7 just moving about their own positions. Bracket close. This is for this specific arrangement. But how many more times will the same arrangement happen? Right? When this A moves here, this A moves here. So reference this A and think about it. One time here, second, third, fourth, fifth, sixth. So 6 cases will be formed. And you can just go for multiply by 6. Is that all? See, no more than 2 means 0, no greater than equal to 2. That means at most 2, right? Greater than equal, actually less than equal to 2. Oh, oh, did I say greater than equal to? My bad. Less than equal to. This will be less than equal to. Oh, thank God. My bad. The context was right, just inequality थोड़ी सी गलत हो गई. My bad. Less than equal to 2. This is your inequality. My bad, people. No more मतलब 2 या 2 से कम. सही है? 2 or less than 2, but not more than that. My bad, my bad, my bad. Okay, so hope that helps, and let's get you the answer, please. So that's going to be 8 factorial plus 7 factorial into 7 plus 7 factorial into 6. So your final answer is 105,840. Answer. See, an easy part. There we go. Just make sure you're considering all the cases, making sure you're taking care of anything that is repeating, and understand the keywords. That's where most people lose their marks. So here we go. Next part. Okay, so we had two questions. What a paper that would have been, right? Two questions of PNC. So 1 mark here, 3 marks here. That's 4, 5, 6, and 10 marks. 10. Let's get these free marks. So please, that's why I want you to focus on this chapter a lot, because we do not want to be fooled by the examiner or lose these pointless marks. Anyways, here we go. 21 students की class है. 10 violinists. Okay, so I have 10 violinists and I have 6 guitarists. ठीक है. Make your distinctions always, please. It's easier. 5 pianists. So I have 5 pianists. ठीक है. A group of 7 has to be created. A team of 7 needs to be created. Okay. From these 21. So 10 plus 6 is 16. 16 plus 5 is 21. That's it. That's my met. The group of 7 will contain 4 violinists, 2 guitarists, and 1 pianist. So in how many ways can the group of 7 be chosen? Chosen is your keyword. So now you know it's a selection question. You simply need to show that a team of 7 consists of 4 violinists, 2 guitarists, and 1 pianist. That's an easy part. Let's get it over with. So out of the 10 violinists, how many do I need? 4. Any 4. Then until the team is not complete, I multiply. From the 6 guitarists, I need any 2. And from the 5 pianists, I need 1 only. Any 1. And that is my answer. So that adds up to 10c4 into 6c2 into 5. We get 15750, 15750 ways of different arrangement. There we go. Different selection, sorry. Okay, that's that. Next part, next and final part. 4 marks for this one. Something related to, I guess, the amount of guitarists, etc. So, on another equation, a group of five, okay. First, let's bring back the distinctions. That was 10, 10, 10 and violinists, 5 pianists, and 6 guitarists. That's our distinction. Now we need to form a team of 5 this time. Okay, what are my conditions? The group must contain at least 2 violinists, at least 1 guitarist, and at most 1 pianist. So at most would resonate to less than equal to, as in no more than 1 pianist. That would mean having 0 pianists, one pianist in our team of 5. Now at least translates to greater than equal to 1, and at least 2 translates to greater than equal to 2. So just like we did once before, I remember somewhere, yeah, right here, when the same cases needed to be considered, because I was selecting 3 digits, whatnot. I made a table, right, to understand how many cases I need to consider. So for our own ease, we'll do the same here. Violinist के लिए अलग column, pianist के लिए एक और guitarist के लिए एक और. Column made. Now let's think about it. A team of 5. Okay, my bad. I don't know how I keep changing tabs again and again. Anyways. Yeah, the trick is to always start from the most basic case, fulfill all the conditions, and then move on to the other case by increasing slowly. So how do we figure out the most basic case? Well, at least pianist और guitarist पे तो at least की बात है, right? मतलब बढ़ाना है वहाँ. लेकिन pianists we have at most 1. That means less than equal to 1. So clearly I know I can consider 0 pianists, but nothing less than that. So I will start making my cases from 0 pianists. So 0 pianists for now. Now violinist and guitarist. These have to be greater than equal to 2, and these have to be greater than equal to 1. ठीक है? And this has to be less than equal to 1. Got it. So how can I make 5 with these two people, the violinist and guitarist? I can make 2 here, 3 here. That satisfies my conditions. 3 here, 2 here. Still 0 here. That satisfies my condition. What else? Still 0. Still at 0. Still thinking. Okay, how else is 5 made? 2 plus 3 is 5. 1 plus 4 is 5. ठीक है. So 1, I cannot go for 1 here, right? So that would be a stupid move. Instead, I can go for 1 here because it's at least there. And here I can go for 4. So that's that. How else? 1, 4, 4 cannot go there and 1 cannot go here. So we're good there. Is there any other way I can make 5? I don't think so. So I can now increase my pianist by 1. And that's the final way I can increase this pianist. Now the pianist cannot be increased by another amount. So now I need to make 4. So 2 here, violinist, 2 guitarist is another way to make 4. Is another way to make 4. How else can we make 4? 3 plus 1, 3 and 1 make 4. Yeah, that's pretty much it, right? Yep, see, that's it. And that is all my cases. I am pretty sure that's all my cases. 1, 2, 3, 4, 5. 5 cases we made, and I don't think there are more because every time I dealt with at most, I thought about how many ways I can make 5. Fix one thing, think about the rest, right? And just increment until you are done with all the cases. So now let's just do our selection. How many violinists? 10c2 in the first case into 0 pianist out of the 5 and 3 guitarists. Next we have 10c3 into 5c0 into 6c2. Next we have 10c4 into 5c0 into 6c1. Next we have 10c2, 5c1 and 6c2. There we go. And lastly, we will have 10c3, 5c1, and 6c1. Okay. Okay. Yep. That makes sense. Okay. So our 5 cases add up to, let's see what they add up to. Okay. 10c2 into 6c3 plus 10c3 into 6c2 plus 10c4 into 6c1 plus 10c2 into 5 into 6c2 plus 10C3 into 5C1 into 6C1. Okay, so my final answer adds up to 10,935 different ways of selection. And that is my final answer. We are done there, people. Hope all this made sense, and that is our variant 2. Not that hard. This part was definitely a tough pickle, but this was also a good part, this one. But not necessarily impossible. Just focus on the keywords and all the cases, right? Moving on to our one and final question, which is the variant 3 questions. Here we go. Question number 6. Find the number of different arrangements of the 9 letters in the word happiness. ठीक है. 9 letters moving around, 9 factorial. Divided by anything that repeats. 2 p's repeat, 2 s's repeat, 2 factorial, 2 factorial. There we go. Answer. Sorry. Moving on. There we go. There we go. There we go. Okay. Part B. Read up while I get some water. Please keep yourselves hydrated throughout. Hanji. Find the number of different arrangements of the 9 letters in the word happiness in which the first and last letters are not the same as each other. ठीक है? इसमें क्या है? Okay, but we need to manually adjust for these repetitions. That is something we'll have to do. Let's think about it. For the first 9 letters में पहले 9 letters की जगह बना देते हैं 1, 2, 3, 4. Now, this position and this position always has to have different letters. Okay. So for one case, I don't know how many cases this will have, but for one case, let's just think about the P's and S's being in between, as in this area, the P's and S's will be here, and the non-repeating letters will occupy these two positions. So think about it. P's and let's just forget about the P's and S's for now, because I want these to be in between. And these two positions will occupied by the two non-repeating letters. How many non-repeating letters do I have? I have H, A, I, N, E. 2 plus 3, 5. 5 letters. Okay, so out of the 5, any two will occupy these two positions at the ends. Got it? I told you, combination, selection, factorial, all about context. So the context of this selection is 5C2, matlab 5 out of the 5, any two will stand on these two corners. And these two will always be different, right? Now, for example, H takes this place and E takes this place, right? Now, they've mentioned that the first and letter, last letter must be different, right? Not the same as each other. So these two can also move about to give you a different arrangement each time. So this is going to be a permutation right here. 5C2 into 2 factorial. These two can be selected there, stand there and move about to give you a different arrangement each time, right? And now moving on to these two positions, we filled those two. How many left? 1, 2, 3, 4, 5, 6, 7. 7 left. That's just going to be 7 factorial divided by the P's and S's that are repeating. That's all. That's one case. Now, why do I say that's one case? Because there are more. Why? See, you need to think about it. Think about it this way. What if a P takes this place and an S takes this place, right? That is still different letters on each side, and nothing will be repeating in between. What if there's a case when the P is at this end and any of the non-repeatings are here, right? So what if an S is here and any of the non-repeating numbers are here? So all those cases will have to be considered. So let's start considering them, please. Okay. So plus second case, let's just go for P and S at each end. So 1, 2, 3, 4, 5, 6, 7, 8, 9. S being at this end. So now for these two ends, we have 2 factorial. P's and S's are fixed, so 1 and 1 for both of them. And 1, 2, 3, 4, 5, 6, 7. 7 factorial for this. And does anything repeat? No. Why? Because think about it. Happiness. I've made sure the different letters at the ends are P and S's. Because see, this time in my first case, P's and S's were in between, not being considered at the ends. But if I consider this case, that the P and S can be at the end. So now that's a different arrangement. So always consider everything. Right now this P has been used, this S has been used. Now the rest of the 7 positions are 1, 2, 3, 4, 5, 6, 7. The 7 letters that are being moving around over in these 7 positions. Nothing repeats there, right? So that is that. Let's make one final case. Plus 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the final case would be that a P is here, right? And the two S's will be in between. And out of the non-repeating letters, because NS has been considered here, right? But P with non-repeating letters has not been considered. So one here, one goes there. And out of the 5 non-repeating letters I have, any one will occupy this last position, right? I'll make an arrow for you. So that position is filled by any of the 5 non-repeating letters, right? Any of H, A, I, N, E. Any of those will occupy that position, right? And if you have the question, sir, what if S takes that position? Well, sir, please, I've already made that case separately, right? Hope that is clear. So 5C1 for that, and for the remaining people, I have actually there is going to be a 2 factorial here as well. Why? Because any of the letter that makes it here, for example H, these two will move about as well to give you a 2 factorial, right? So this is combination. This is factorial. Permutation was taken into consideration over here. So all of these things are making their way into this question. Okay, so now for the remaining letters we'll have 7 factorial. And does anything repeat? One P has been used here. So there's only one P in between and two S's, right? So I'll have to divide by remove the repetition of the two S's. That's it. But sir, we're not done yet. Why we are not done yet? Because the same thing can happen if an S takes this position and any of the non-repeating letters occupy this position, right? So instead of making a whole another case, I'm just going to do one thing. I'm going to do this. I hope that made sense. Why? Because look. It is the same thing. And if ns takes this place, I'll go for fixing the s. Think about any of the non-repeating letters taking that place, into 2 factorial for them moving about their own positions, and then 7 factorial for in between, and the p's 2 p's repeating, divide that, and it's the same arrangement, right? But only the context is that p is in this place and the context changes when an s is in this place, right? So there's simply, if the arrangement is same, I can just multiply it back. Got it? So that should be every case. We have considered every case, right? And let's get you the answer. Think about it, clear yourself, feed this into your head, the thought process, until I get you the answer. Divide by 2 factorial into 2 factorial plus 2 factorial into 7 factorial plus 5C1 into 2 factorial into 7 over 2 factorial into 2. So the final answer is 85,680 ways. ठीक है भाई, I hope that made sense. Let's do a recap for this. So they said we need the first and last letters to always be different. Okay, तो हमने कहा भाई repeating letters को भूल जाते हैं पहले. Let's put the repeating letters in between and only use the non-repeating letters to be at the ends. That's one case. Now thinking about the letters that repeat manually. Manually we placed the repeating letters at each end and moved them around and did one case is that. Then the other case included, the final case included that one of the repeating letters was at the end while the other end was occupied by a non-repeating letter. And we did that with the P and with S, which is why we have done a multiplication by 2, because it would have been the same arrangement, right? Hope that is clear, people. Last part. Okay, we have 2 more parts. Good lord. Let's get it over with. Find the number of different arrangements of the 9 letters in the word happiness in which the 2 P's are together, and there are exactly 2 letters between the 2 S's. How many times have we done this? Come on. In my techniques video, you can find the way of doing this. Simply make your positions 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 2 P's being together satisfy the first condition. This is a double condition question, by the way. So the method is simple. Make the positions satisfy the first condition, box that up. Satisfy the other condition, exactly 2 letters between the 2 S's. So S here, 2 positions between. Box this condition up as well. Now we will first work inside the boxes. One inside this box is just going to be 1. Inside this box, these 2 positions are not filled yet. Now there's a distinction between inside the box and outside the box, right? So I'm going to make a selection. The P's and S's are being used manually. So remove that from the happiness word and think about the remaining 5. 1, 2, 3, 4, 5. Out of the remaining 5, any 2 will occupy these 2 positions and they will move about their position to give you a different arrangement each time. The S's are fixed, so you can add a 1 and 1 there for your own ease. And now we're done with inside the boxes. Now outside the box we have 1 box, 2 box, 3, 4, 5. And that is going to be 5 factorial. This is a specific method for this question. See how many times have we seen it? Like 3 to 4 times in the past 2 years. So that is why I taught you this method a little differently. So our final answer, people, is 2400 ways. 2400 ways. Oh, actually, wait. We're not done. We're not done. Why are we not done? Please think about it. I told you, we have to think about that when we do this method, we consider everything, but we do not consider these two p's being together, making it inside the differentiation of these two letters s's. Now, if these I would have thought of this because if I put this both the three p's together and put them in then the condition will be like, because there's two letters going to be two, so I put these right, and I will not have any condition because these are together. So, but in this case, there are only two p's, and there has to be only two letters between the two s's. So I will make one more case. And that one more case is going to look something like this. It's going to look like this. 1, 2, 3, 4, P, P, S, 5, 6, 7, 8, 9. I hope that is making sense. This specific arrangement where the two P's are also found inside the box. I hope that makes sense because I've complicated it a lot. These are all fixed, by the way. They cannot move about their own positions. Why? Because the S's have to have two letters between them, and they can have these two P's in between them while the P's are together. So outside the box, 1, 2, 3, 4, 5, 6. 6 factorial there. Does anything repeat? Nothing repeats. There we go. Now we're going to get the final answer. 2400 plus 6 factorial. So the final answer is 3120. Because, see, in this case, in this whole scenario, the P's will never make it between the two S's. But if they did make it, if in some scenario they did make it between the two S's, the conditions, both the conditions given by the examiner will be met. And if they are being met, then I have to make a case for that as well. But the first method I use does not consider the P's in between the two S's, right? So I'm going to do that separately. So make sure you always think about that as well. That's something the examiner can play you on. Hope that made sense. That is your final answer. Finally, you have the final part, the 9 letters between. अच्छा नहीं, the 9 letters in the word happiness are divided. Selection का सवाल है. Group of 5, group of 4. Find the probability. ठीक है. That both P's are in one group, both S's are in the other group. Okay. So whenever probability plus selection, we know it's a possible selection question. Make your distinctions of everything that repeats or everything that has a condition on them. P's and S's have a condition on them. Make the boxes. Different boxes for different types. Non-repeating box contains of H, A, I, N, E. There we go. Now we start working on the cases. So group of 5, 1, 2, 3, 4, 5. Group of 4, 1, 2, 3, 4. Group of 5, 1, 2, 3, 4, 5. Group of 4, 1, 2, 3, 4. ठीक है. So group of 5. Okay. So the P's and okay, the सवाल देता है both P's are in one group and both S's are in the other group. That means the P's and S's have to be together and they cannot be in the same group. सीधी बात है भाई. एक काम करते हैं. First, let's put P's in the group of 5 and S's in the group of 4, and then put the S's in the group of 5 and the P's in the group of 4. That's it. Now make your selection. How many P's did we have? 2, all 2 selected. Out of the non-repeating, we'll have these 3 positions filled. Then 2C2 for these 2 S's, and then lastly 2 letters remaining from here. 5 minus 3 is 2. 2 letters remaining there. 2C2 for these 2 positions. 2C2 for these 2 S's. By the way, there's addition here. 5C3 here. Then we have 2C2 for these and 2C2 for that. Oh, that makes sense. Now 2C2, all these 2C2s are just 1, right? So we have 5C3 here plus this plus sign and then 5C3 here. Right, that is our numerator. Easy, simple question. Divide, that is our numerator, right? Possible selections, हमने numerator निकाल लिया. And conventional probability states that favorable condition on top, denominator, and all possible outcomes. And the condition would be out of the 9, any 5 will go in the group of 5, and the remaining will go in the group of 4. So that will be the all possible outcomes of your condition, and then you can get your answer, which is 10/63. Yup, easy question था, जल्दी कर लिया हमने काफ़ी. मैंने काफ़ी तेज़ी बोला because we've done a question like this so many times. But this is pretty much it. All the hard work pays off here. I hope I was able to provide you with some aid in this hell of a topic. Most people, most of my friends, and even myself hated this chapter in the beginning, but then it made sense if we go about it the right way, right? So I am honored to have passed down this knowledge, and I hope it helps some people out. If the 2025 questions come out soon enough, I will upload something about that as well. And let me know what next chapter of S1 do you want me to cover in the comments. I'm probably going to do normal distribution next. That's on my list. And yeah, so I will get on that real quick. Do this chapter justice and yourself as well, please. Your parents have paid good money and make it count.